Hey, party people. For those of you who are afraid of doing any more uniform motion problems and are probably thinking anyone who likes to do them are squares, I've got good news for you. We're going to work with not squares, but rectangles. Rectangles, slightly more exciting than squares, as you can see by my Google image search. What am I talking about? I'm talking about area. We're going to do problems with area now. And you know the formula for area, don't you? Of course, it's length times width equals area. Now, in these problems, it's a little more complicated, so guess what? We are going to make a chart. Dun, 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 dun. And it's going to look just like our old charts, except we have a new formula. So as I draw this, think about this. You know the formula for area. So what are we going to write in on our table? Of course, we're going to do length times width equals area, and that's very similar to distance times rate, or rate times time equals distance. And it really is going to work the same way. You'll see. So as I start this problem, what are the two things that you think should go over here? Well, we have two rectangles, so let's put the original rectangle and then the new rectangle, right? We make it bigger. So in the original rectangle, what is the length and the width? Yeah, and you should say, well, it's 5 centimeters longer than it is wide, so call the width x, call the length x plus 5. Now, to be fair, you could also say this is x minus 5, and that this is just x over here, if you want to call it the length x, but we'll go with this for now. And likewise, how do we figure out what goes into the new length and width? We should increase each by 3. So in other words, we're going to get x plus 8, because that's x plus 5 plus 3. 5 plus 3 is 8. And then, well, we're going to add 3 to this x, and we'll get x plus 3. Well, that's just x plus 3. And now, what do I have to do to figure out the areas? Okay, well, I'll do this one if you do this one. When I multiply these, I'm going to get x times x is x squared. And then I have to distribute this x, and I'll get x times 5 is 5x. Multiply these for me, and I'll give you a hint. You might want to use the box method. If you multiplied it correctly, you should have gotten x squared plus 11x plus 24. Now we have to do a little thinking. It says to find the original area. Well, let's just read the problem. It says the area was increased by 60 centimeters. That means the difference of the areas, difference, keyword there, of the areas is 60. Now, I know we're not used to subtracting things. In fact, all of our equations have been adding, but we can actually finally subtract our areas. I know we haven't done that before, but think about it. This is the larger area. It's the new one. So we're going to take that, and we are going to subtract the other one from it. And I'm just going to go ahead and write this out using the hamburger method, if you remember how to subtract polynomials. X squared is 5x. And I'm just going to say that I'm subtracting this entire thing. I'm going to put it in parentheses, and you tell me, what do I get? It should just be 6x plus 24. You did that right. So notice our x squareds go away. We don't have to deal with them, and we get, well, these two are equal to, by the way, in the original equation, these two were equal to, what was the difference of their areas? 60. Oh my, that was a lousy 60. Sorry about that. And now, can we solve this equation? Do that for me really quick. Do it correctly, subtract 24 from both sides, you should get 6x is equal to 36, I think. Yeah, I'm right. And then divide both sides by 6, and you'll get x is equal to 6. Now hold up. What did the original problem ask us for? It asks for the area of the original rectangle. So how would we find that? Go to the original rectangle column and look for area. So original area. So original area. Oh, where do they meet? Right here. We're looking for this. So what are we going to do? Plug it in, plug it in. Do that for me. Plug in 6 into this. What do you get out? Oops. Hopefully you got out 6 squared plus 5 times 6, which another way to say that is 36 plus 30. 36 plus 30 is 66. So the area of the original rectangle is 66 centimeters squared because it's an area. Seems like a tricky problem, but really it's just the same. We're still using a chart. And by the way, this is the last kind of problem we're going to use a chart with for this semester, so we can kiss them goodbye after this. If you have any questions on what I just did in this video right now, now would be a good time to raise your hand. Or you can always rewatch it by clicking the YouTube link on the Google form on the WebQuest, and that way you don't have to answer all the questions again. Just watch the video, and there won't be any breaks in it. Thanks, guys.